these countries are extremely poor, mainly because they don't have electricity. So as soon as you bring electricity into a community, like you're really transforming that community and that country.
Hello, everyone. I'm Anand Jha, and you're listening to the Oil and Gas Breaking By show. Today, I'm happy and excited because we'll be joined by Yvotte Brits, Chief Reactor Technology Officer at Paragon Energy, with deep experience in nuclear energy and the energy segment. He has led many complex technology projects, operations, and supply value chain to develop advanced nuclear technologies. So today's conversation is about nuclear and the reactor technology, and also we will talk about biases around nuclear energy in terms of safety, risk, and its role in the future mix of energy. So with that, let's deep dive into Yvotte's journey and also get his views on the future of energy. Yvotte, thanks for joining me today.
Anand, thank you so much. Really a big privilege to be on your show.
Thank you, Yvonne. And as I was mentioning you before, your journey is very interesting. And also this topic, this nuclear topic, we talk a lot about it. Like during CERAWeek, if you remember, there are lots and lots of curiosity around this nuclear topic. So today we will talk about in and out of this technology. But before we deep dive into technology itself, I will start with your journey, which is also very interesting. So let me start with the why. Why have you been in this industry and what draw your attention to nuclear technology?
Yes, Anand, excellent question. So just to give you a brief background, I am Yvotte Brits, originally from South Africa. I was born and raised in South Africa. And South Africa did had quite a big nuclear program when I was at university, the Pebble Bed Modular Reactor Program, and then basically recruited me to do my master's degree in nuclear engineering, for like which like I'm really thankful for. But just to give you the story behind the story, and this is a personal story, but also important, just to share why I am where I am. Like I'm a Christian. I believe in the Lord Jesus Christ. He have changed my life, many years ago. And then after that, I've started to do a lot of mission trips. I went to a lot of countries to go and to preach the gospel. So Zimbabwe, Mozambique, all over Africa, Middle East, and even North Korea. I had the opportunity to go there. And then a couple of things that I realized is that, these countries are extremely poor, mainly because they don't have electricity. And I immediately saw the need for getting electricity into these countries. But then during that time, I did feel that God spoke to me. He told me that, these short-term mission trips is great. But if we look at the Apostle Paul in the Bible, Paul have done a lot of these short-term mission trips. But Paul realized, listen, if I want to preach the gospel to the whole world, I had to get into Rome, because 2000 years ago, there was no Facebook, there was no internet or anything. And then if you want to say anything to get it around the globe, you had to say it into Rome, because Rome was the empire during that time. They had outposts all over. So everything that you said in Rome, that was propagated all around the world. So long story short, the last place that Paul visited was Rome. He was able to preach the gospel to Caesar. I'm not sure how he pulled it off. And then the last book that he have written in the Bible was the book of Romans, just before he get killed. And then what I felt, God told me is that Rome today, basically in, 2000 years later, this is energy, and specifically nuclear energy. So to get the gospel out, I have to get onto the energy and onto the nuclear energy platform. And this is how I could help people. So this was really like my calling, my own personal calling. And then, God have really blessed me with the opportunities to study bachelor's of electronic engineering in South Africa, and then my master's degree in nuclear engineering. And then I got the opportunity to come over to the US in 2015, with the X Energy program. And I was able to do my PhD in nuclear engineering at North Carolina State University. But this is really the why I'm in nuclear power. I really believe that this can change the world. This can really uplift communities, but most important, this is a way to get the gospel out to people so that they can enter into a relationship with God and be saved.
Oh, it's amazing, amazing story. And when you talk about the basics, like normally we talk about the food and the roof or water, but in today's world, energy is one of the basics for human life. And especially the countries you talk about, they are energy hungry. So we can do many things, but if they don't have energy at the right price, they cannot make much changes. They cannot develop themselves. And there are many examples where the country had ambition to do something different, but when the LNG prices and all the gas prices went up, they went back to the coal. So what you just said, I fully agree.
Yes, absolutely, Anant. And just to, make the point there, I've been in a lot of those countries. Maybe one example is Zimbabwe. When there's no electricity, they have to cook on a fire, they have to boil water on fire, so things that we really take for granted, just to switch on the light, turn on your stove and basically cook a meal in like 15 or 20 minutes, that will take them 4 to 5 hours because they have to, chop the wood, get that. They don't have a fridge. So all of this takes a lot of time, and then like there's no schooling. It's like super hot during the summertime, so these guys have like school under a tree, so they cannot really uplift themselves, and there's really no outlook. So as soon as you bring electricity into a community, like you're really transforming that community and that country.
Fully agree. We'll come back to this energy discussion, but let me talk about your career, because you grew from your engineering to leadership role. How was that journey, and what helped you to achieve wherever you are today?
Yes, absolutely, Anant. I was really blessed throughout my career with like great mentors, great leadership roles. So I started off my career at Nexa in South Africa, the South African Nuclear Energy Corporation. We had like a test reactor there, and we were making molybdenum 99, so the medical isotopes. I worked there for 2 years, and great managers, great people to look up to. And then after that, my professor from university in South Africa, Professor Eben Mulder, he's one of the best nuclear engineers in the world. He recruited me to join him, and also another guy with a startup company, so Dr. Martin van Staden. So I was like really fortunate to work under these two guys, which is great leaders, great technical mentors. So we started like the first company called Steenkamp Thorium Limited. That's Afrikaans name. I know it's quite difficult just to pronounce, back in 2011. And then like the group grew. So I was able to touch every single piece of the design. And then from there, went to X Energy. So like the founder of X Energy, the billionaire owner, Dr. Cam Kafirian, great guy. He came to South Africa. He recruited a couple of engineers, and he brought us over to the US, just to start X Energy. So I was employee number 4. I started at the 2013, and then basically came over to the US full time in 2015. And in there, like I really have basically learned all the technical skills, so I was able to touch every single piece of the design, the reactor, the steam generator, the plant, the helium systems, the plant operations, the costing side, the supply chain. That was extremely good time. And we really got like great leaders in X Energy. So the current CEO, Clay Sell, he was in the White House. Like the Undersecretary of Energy, great person to look up to. So I had all of these mentors around me. And then just naturally, like my career did grow, from a junior engineer to a system engineer to basically like engineering manager, and then director of both supply chain and director of plant operations. So the great thing is, in a small startup company, you do everything. I mean, like you don't have one job, you have 20 jobs.
Yes,
And that was the case for me at Xenergy. I mean, if you put up your hand, they will like throw 20 jobs at you, which was fantastic. So like I've done the design of the plant. I've stood up the full instrumentation control team, the simulator, human factors engineering, team of about 80 to 120 people, great people. And then in parallel, also building out the supply chain for X Energy, building out the cost modeling. And then from there, X Energy really got a pivot, like a pivotal point in 2020 when X Energy basically have won the Advanced Reactor Demonstration Program funding from the Department of Energy in 2020. So that was a $2.4 billion award. And that was an inflection point for the company. So the company grew from 20 people to today, like I think they've almost about 1,000 people. So from there, I was promoted to both the director of plant operations, director of supply chain, and then really got great people in my team, great people around me that have mentored me, that have helped me just to grow. Then X Energy promoted me to the vice president of supply chain, and then I was able basically just to oversee the supply chain, build out the team, build business models, make sure that the supply chain is scalable, so that we can build reactors all over. And then one of the prior suppliers that I've worked with, that I've immense amount of respect for, so both Paragon and Marion, So the CEO of Paragon, Mr. Doug Van Tassel, we have a very good relationship. We've been working together for about 5 years. They have designed and developed the reactor protection system, Newton monitoring system for us. Basically, he convinced me just to join Paragon. So like I had like a off period between after X Energy, I did enter like the concrete business a little bit, green concrete. So I was vice president procurement supply chain for Brimstone. It was great. I love it. I love what the company is doing. The CEO Cody, great vision. But during that time, Doug gave me a call and told me like, listen, man, you're a nuclear guy. Please come and join my company. And he gave me an offer, just to become the Chief Reactor Technology Officer. And then, as I said, like I have a tremendous amount of respect for Paragon and Miriam about what they are doing, and Doug, and then also my current boss at Paragon, Ty Smith, extremely good leaders. So I was able basically to go over to Paragon. So for the last year, I've been like the Chief Reactor Technology Officer at Paragon, and of course Miriam did bought Paragon last year in December, and like also have a very good relationship with them. So extremely blessed. But this is in a nutshell how my career progressed. So I've really started at the bottom, doing every single thing of the design, writing all the documents, doing all of the donkey work, and then from there, slowly but steadily progressed over the last 20 years from engineer to engineering manager to director to vice president, and then currently like the Chief Reactor Technology Officer.
Amazing journey, amazing journey. And we talk about few things like starting with the small company. There's always a benefit because you learn a lot because you are doing many things at the same time. And just one question, during that journey, like you have changed countries, you have changed roles, you have changed even the work you were doing. Any stereotype or bias that you came across, and do you want to talk about it?
Yes, no, this is absolutely, so yes, so came from South Africa just to the US. And the amazing thing for me about America is like they get stuff done. I mean, America decides like, listen, we're going to send somebody to the moon, then they do it. When they say like, listen, we're going to build a reactor, like they built reactors, not a single one. I mean, and a good testimony of this is, I mean, like there's a couple of reactors going critical just by 4th of July. I mean, if we look at like all these startup reactor companies in the US, it is phenomenal. I mean, you have X Energy, TerraPower, NuScale, great companies, all these suppliers, So this was really something that I did pick up. America really gets stuff done. Like they do mega projects, like they pump a lot of money into that. West of Africa, awesome, great country, but I would say it's like more reversed, more, we have to be careful, save money, like we cannot just throw money at the project and go for it. But in America, it's amazing just to see how they build and how they scale, and really how the sky's the limit here.
Yes, I fully agree, and that's why we call it this country is a country of opportunities. So lots of
Absolutely.
opportunities for everyone if you want to excel. Switching to our nuclear technology and the nuclear energy itself, we always talk about how great this solution can be, but there are lots of perception around this nuclear energy. What are the perceptions versus reality that people should understand?
Yes, no, so it's like great question, So I think in the past, there was a perception that nuclear energy might be unsafe and people had a fear of the spent fuel, but people have overcome that. People understand today that nuclear energy basically is extremely safe. It's baseload power. It's really good for the community. And this is a testimony today. I mean, the EIA or the Atomic Energy Agency basically have put out a report where they said that today there's 170 startup new nuclear reactor companies. And I mean, this is just a testimony that like people is believing the nuclear story. They are going into that. But I would say today in 2026. Definitely, the perception is maybe that you can do nuclear faster than what you can. So nuclear is still nuclear. You have to go through the full design. You have to get it licensed. You have to get a customer. Basically, you have to make an economically viable business case. All of this takes years and years. I mean, this is not a quick fix. So maybe one of the perceptions is that nuclear can solve power today in 2026, where it's maybe more in the 2030s, which is a more realistic timeline and stuff. But as I said, like a previous or a prior perception that it is unsafe, that have totally been debunked. Nuclear is one of the safest based sources out there. But today is the speed of scaling. How quickly can I build multiple reactors? What is the reality with my supply chain, with my EPCs building it out? And then, of course, also just to put all of the pieces in place. So to get a nuclear program up and running is extremely complex. Like it's really expensive. You need to have all of the people, you need to have the finances, you need to have an off-taker, you need to have an EPC, you need to have like a government standing behind you. And luckily we have that today. But like you have to really solve all of these stakeholders and make sure that everything aligns so that you can get the reactor in the ground.
Makes perfect sense. And you talk about the technology have evolved a lot, and one of the biggest concern you already mentioned about is the safety. What innovations are there? Like, if you can summarize for us to our listeners, what are the innovations are there to overcome that perception of safety?
Yes, absolutely. So if we look at nuclear reactors today, like they're really, classifying them between a generation 1, 2, 3, and 4. So the current fleet of reactors, I would say, like the older light water reactors, all of them is a generation 2 reactor, mainly where you have like active cooling on the reactor core, so you can still get a core meltdown. So you have to actively cool it. If you don't, you get like a Fukushima or a 3 Mile Island. And then most of the reactors today is progressing to a generation 3 reactor, just like NuScale. And this is where you have passive cooling on the core. So like you don't need the active cooling anymore. So, really safe. But then we also see a lot of generation 4 reactors today, like X Energy, like Valor, like a lot of other basically designs out there. And this is really where the reactor is walk-away safe. So it is impossible to melt a core. Like there's no core meltdown frequency. No matter what you do, you cannot melt a core. The physics of the design in the reactor that is protecting basically the reactor. So, for example, the X Energy design have a very strong temperature and negative temperature coefficient. So if they go into one of, like, let's say, like the worst events, which is a depressurized loss of forced coolant, they are losing all of the helium, the control rods cannot insert. The temperature will go to the maximum temperature after 18 hours, and then the strong negative temperature coefficient that will just shut the reactor down. So like you definitely don't need operators there, you don't need any active systems, but this is how safe these reactors are today. And then on top of that, what my company is doing, Paragon Meridian, we are providing the reactor protection system. So we have the best of the best. We call this the HEAP, the highly integrated protection system. This is a field programmable gate array system that like really acts as a digital reactor protection system. So we are really keeping the public safe. For example, let's say your reactor outlet temperature goes above the maximum, then the reactor protection system, or the HEAPs, that will immediately actuate protective action. So that will send a trip signal to the control rods to insert it. It will shut it down, make sure that the public is safe. So I would say basically dualistically, the reactor designs today is like very passive, very safe. Like there's no active systems needed to keep it safe. But then also on the supplier side, like Paragon and Meridian, we are really developing cutting edge technology, the best safety systems known to mankind, just to keep these reactors safe and to keep the public safe.
Makes sense. And in the terms of leadership and policy, what do you think? How it can help to promote this technology more and more? Because there are different types of energy resources from coal, gas, oil, geothermal, where this technology fits in this whole value chain, and how leadership and policy can help.
Yeah, absolutely. Great question. So if we look at the power demand today, mainly driven by data centers and hyperscalers, like there's definitely a place for everybody. Like there's a place for nuclear, for gas, for coal, for solar. Everybody needs electricity, energy. There's a massive energy crunch. So, nuclear really comes in with base load power, so to run a country, you need base load. Solar and wind is great when the sun shines and when the wind blows. But when it doesn't, it's not a great base load source. But I know in South Africa, there's a lot of solar, a lot of wind. My parents on our peach farm in South Africa is running the whole farm from solar panels, and it works great. But for base load power, we have a lot of industries, like you do need nuclear. So this is where nuclear is extremely important. And then on top of that, in the grid in the US, where you have a lot of intermittent sources like solar and wind coupled to your grid, like the load following capability of nuclear and a lot of these new nuclear reactors is extremely important, just to make sure that the grid is good, to balance the grid out. So with a lot of these nuclear reactors, you can do load following at the rate of 5% per minute, run it up and down, and then balance out the intermittent power sources. But just to summarize, like the place for nuclear is base load power, and then also basically load following, a lot of these new reactors. And this really helps like a country and the economy on the long term, just to have reliable power. And then your question, how can leadership and policy help? So like I think we are seeing today like the best leadership in nuclear in the US history, where there's a reform in the NRC. Like we do see that companies like TerraPower got their, Part 50, the construction permit, approved within 18 months. X Energy will also get theirs hopefully in like 18 months. So we do see these shorter licensing, review timelines, and this is helping a lot. But if policy and leadership can like really put a policy and the regulations in place to just to help nuclear rather than to stop it. And currently, like we are seeing this in the US today, that policy leadership is helping nuclear just to get it in the ground and so on. Especially take into account that the nuclear program is really expensive. It's a very high risk. It's very complex. So if you can get a tailwind instead of a headwind, like it goes a long way.
Makes sense. So when you talk about the loss of demand and also you talk about technology is changing a lot, how can we balance the precision and the speed? Because with this technology, you cannot take any risk. So how can we manage both?
Yes, no, so excellent question. So basically precision and speed. So basically one of the lessons learned from nuclear. So nuclear in the past do not have a very good track record. Like it's always going over budget, over cost. So one of the big lessons learned is to complete your design 100% before you go into construction. So this is one of the big learners, from the Vocal project and from other projects, is to complete your design 100% before you start with construction. And although like it feels that it's taking longer, if you look at the netto speed, like you're really going to save time. So this is really going to help you. So the first one is make sure that your design is complete, and then you start to construct it. Also, basically make sure that all the stakeholders is in place. There's a good business case, and also that you do have the workforce, and basically go through like the correct regulations. I mean, in the US today, you have Part 50 and 52. So Part 50 is the typical two-step approach where you do your construction permit application, then your operating license. So your construction permit is allowing you just to construct earlier, but then 52 is helping you just to license your design. And then also Part 53 just came out recently. So make sure that you select the correct licensing regime for your project, for your stakeholders. And that, most important, that I've iterated on this a lot, is to make sure that your design is 100% complete before you start construction.
Makes sense. And today we have a tools like that. Like you talk about the digital simulations and all those things. I think which they're much advanced than what we used to have few decades ago. I think that also helps.
Yes, absolutely. So today, like we are speaking about 3D and 4D scheduling tools. So the total plant is digital. You have this on a tool set like Smart Plant. You can couple this with your P6 schedule, and then you can couple this with like software just to see how your construction is progressing. And then there's also 5D BIM. So like really great tools out there. So make sure that you use the latest and greatest just to make sure that you know where you are on the project, like you're not making any unnecessary mega project mistakes, and that, like you are using like the tool sets that's like available.
This is a very fascinating world of nuclear. Like we always hear about it, but not many people have experience dealing with the nuclear technologies or nuclear energy in the past. So if somebody wants to make a career in this industry, what skills and mindsets they should have?
Oh, yes. So today, like a nuclear program is not only employing nuclear engineers, but really a myriad of like different functions. I mean, in a nuclear program, like you should really see this as a team. This is a team working together. You need finance people, you need business development people, you need basically graphic designers, just to really get your message out there. And then, of course, you need all of the engineering disciplines. Your nuclear engineers, you need mechanical engineers, process engineers, electrical, INC, chemical engineers. So if you want to make a career into nuclear, I would definitely advocate for people just to go and to spend a day with a company like NuScale or X-Energy or TerraPower, or even come to Paragon or Miriam. We will be glad to show you around our facility. We have a 100,000 square foot facility here in Fort Worth, Texas, like a multi-reactor simulator. So we have a simulator for every single reactor in the world. We are building the equipment here. So like we show them what it's all about, and then basically decide what is your personal beliefs, what do you like, what is your interests. If it's finance, go into finance, and then pivot to nuclear. Or if you just want to directly go into nuclear engineering, you can do this. But if you look at a nuclear company today, a team that is between 500,000 people, you really have like every skill set in there that you can think about. Even IT, HR, I mean, every single company needs IT or HR. That is always there. But like really any skill level can like get involved with like nuclear energy.
It's amazing. So this open for all the disciplines. So it's not about just a nuclear scientist, because from outside it looks like if you're not part of that group and if you're not a nuclear scientist, you might not have an entry in this industry.
Yes.
But that's not true. You just mentioned about it. I think that's open for everyone, and also it helps to bring a diverse perspective to this industry. So good to know there's opportunity for everyone. So our listeners, if you are interested in this nuclear energy and nuclear world, I think it's not too late. There's always opportunity to join this growth, because I also see coming back from Saravik, I see there lots of focus on nuclear, and nuclear is going to play very important part in this energy demand and energy generation going forward.
Yes, absolutely.
Yes. That also brings us to our rapid fire round, Yvotte. Are you ready?
I'm ready, man.
Let's see how ready you are. Most underrated strength of nuclear energy.
I would say basically like the long-term value, like the long-term economic benefit value, so if you basically build a nuclear power plant in a town, it's not only the direct jobs, but all the indirect jobs that you're creating. So all the schools, all the people that you have, all the indirect jobs. So the economic benefit that a nuclear plant have for the community.
Makes sense. One myth about nuclear you would eliminate.
Basically, a myth about nuclear is that it is dangerous. Of course, it is dangerous, but nuclear is the most regulated power source in the world. I mean, the NRC is making sure, and the regulators all around the world, that like nuclear is extremely well regulated. So as I said, nuclear is the most regulated energy source in the world. It's definitely not dangerous. Like there is basically aspects in there that's dangerous, but everything's like well regulated and like mitigated for.
Makes sense. Safety versus innovation, which is harder to balance?
Safety is like always like the most important thing in the nuclear industry. I think this is the only industry where safety trumps cost and innovation. Innovation, you have to do that stepwise in a safe manner. Like there's a lot of ways to innovate in nuclear. Paragon and Miriam is developing a digital twin for the nuclear energy sector, which is extremely great. But safety is like always like the most important aspect in nuclear.
Toughest decision you have made in operations?
So toughest decisions that I have made in like operations, so I would think about this. So when we started off with the X Energy project, one of the main challenges for us was the levelized cost of electricity, how to drive that down. So if we look at the standard X Energy plant today, like it have 40 reactors, 4 turbines. And then if you just go and look at the regulations, like the new regulations for that, for a 40-reactor plant, you need basically 3 control rooms with a lot of operators. And of course, that will be very negative for your levelized cost of electricity. So we had to take quite a big risk at X Energy just to decide to go for a single control room to operate 4 to 12 reactors out of that control room, so that we can drive down the amount of operators that we have, and also basically decrease like the levelized cost of electricity. So we had to take that risk. basically just to really invest a lot of money and design and build out the single control room, and we were successful. So that was really great. And also, with that being said, NuScale have paved the way. I mean, NuScale have basically successfully designed and licensed a single control room for like 12 reactors. But this was one of the tough choices that we had to make. Are we just going to follow the current regulations, doing free control rooms for 4 reactors, or are we going to really go upstream and do a single control room for like 4 reactors and take the chance that we will be successful?
I will like to know more about this one now because how that changes the innovation, the safety, and other risk. But
Absolutely.
maybe some other time when we meet in person.
Yes, definitely. Absolutely.
Let's moving on. A habit that keeps you sharp.
So a habit that like keeps me sharp, basically. So one of my habits is I go to bed early and I get up early. So basically, if I have a good start in the day, and basically personally, I get up at like 5, spend time with God, and then basically, and then do all the chores that I have to do. But just something simple like that, get up early in the morning. Basically, get to work, do your work, and I know, these nuclear programs feels like an elephant. It's massive, but you just have to do your part every single day. Make sure you're sharp, get up for work, sharp for the meetings, and basically just step by step, complete these projects.
Makes sense. One step at a time. Moving on. Best advice you received early in your career.
Yeah, so basically, best advice that I've received, was maybe to do my master's degree in like nuclear engineering. So back in South Africa, I've studied electrical and electronic engineering. I had a scholarship at the telecommunications industry at Energy in South Africa called Telkom. So I was working there. I was extremely bored for the 2 weeks that I have worked there, because everything was already designed, it was developed. I was just keeping everything there, basically up and running. And then, like I did phone, like my old university and asked them, what programs they have available. And they did advise me to do my master's degree in nuclear engineering. And that was one of the best advices that I got. I pivoted into nuclear engineering, and, that have really basically taken me all around the world and even in the US. And I was able just to work for great companies like Nexa, STL, X-Energy, Paragon, Marine.
What biggest mistake engineers make early on in their career and in their journey, professional journey?
So I think, like they overthink, they overdesign. So you do have to build your product. I mean, like nobody buys a paper product. They want to see a real product. So I think like engineers tend to overthink a design. They need to overdesign. And this is really where perfect is the enemy of good enough. So you really have to decide, when is it good enough? And then build it. And then also in your career, I mean, so when is it good enough to move on?
Yes,
So
you're right.
engineers tend to like they want to make everything perfect, but you really have to say, okay, this is good enough. Now I move on.
Makes sense. And sometimes you're stuck in that kind of scenario planning, like what could have been better and all those things. And then you
Yes,
regret over the time, like why you didn't make that decision at the right time.
yes, absolutely.
Last but not the least, the future of energy will depend upon who?
So the future in energy will like really depend, like I think on all of these new technology providers out there, like nuclear, data centers. Like I really think a couple of winners will be selected in the next 3 or 4 years. This is going to be extremely exciting. I mean, this is currently almost like the Wild West out there. There's 170 of these new nuclear companies, and almost weekly there's new companies. There's all of these designs out there, which is really great. But in the next 3 or 4 years, like I do think we're going to see 3 or 4 or 5 winners. Like we're going to see the data centers, hyperscalers driving the energy demand, but then we're going to see like the technology providers that can really execute on projects. We will see the winners getting out of that, and that will shape the way that we do energy in the future, and then also like the types of nuclear reactors that will be selected.
Makes perfect sense. You did really, really good, Yvotte. I could say that. So,
Oh, thank you,
in the
Anand.
short term, we learned a lot. Thank you.
Oh, thank you, man. Really appreciate it.
Okay, now we're coming end of our conversation, but before we sign off, if somebody listens to this conversation after 5 years, what differently they should think about nuclear energy?
Yeah, so basically, excellent point. So today, as we sit in 26, we see that a lot of these reactors is in the concept basic design stages. in the licensing stages. I think in 5 years from now, hopefully we will see a lot of these reactors under construction. So today the focus is on design and licensing, but over 5 years from now, it should be what is the best execution construction strategies. Like really the thinking is going to pivot from the design licensing more to construction execution. How can I get more reactors in the ground? What is the innovation that I can take just to build these reactors in parallel, and how can I really think about the operations, like the 40 or 60 year operational lifetime that'll be waiting for the nuclear reactors.
Makes perfect sense. So before we sign off, Yvotte, anything to add here?
No, Anand, thank you so much. This is a very, very interesting time. I think we are all extremely blessed to be alive in 2026. This is a great, great time to be alive. This is a great time to be in energy, to be in nuclear, to be in technology. I mean, plants is going up all around. This is a great time. So really enjoy it. I would just say enjoy every day. Like I know projects gets like very stressful. We always think about, like the reactors going operational in 2032, 2033. But I would also say enjoy like the journey, basically enjoy today. You will have like you will never get today back again. Like you only have today. Live today for the fullest, enjoy it, and basically just take what you can out of this, in your crises, in your design, in your things that not working out. Also try to find the joy in that. And then of course the most important message from me is that God loves you guys, and he gave his only son Jesus, that whoever believes in him will not die but will have eternal life.
Excellent, excellent. I fully agree. Enjoy your time, whatever time you have, because life moves on very, very fast. So with that,
Absolutely.
I will sign off today. And if today's conversations breaks your bias and your view about nuclear energy and the reactor technology, so please share your comments and your thoughts. And that's how we will keep breaking bias. Keep listening. Oil and Gas Breaking Bias Show. See you next week. Have a great day.
Thank you so much, Anand. All the best.
Thank you.